Elon Musk has just unveiled the Tesla Optimus V3, a robot capable of operating continuously for 48 hours without rest. Equipped with a 3 kilowatt-hour battery and sophisticated AI, V3 can handle everything from lifting heavy packages to monitoring complex warehouse operations. What allows V3 to fully harness the new generation battery in ways previous versions could not? Before we begin, please help us reach 20,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What is the new battery type used exclusively by Optimus V3? In the world of humanoid robots, few technologies are as critical as energy, the factor that determines whether a machine can work continuously or merely serve as an expensive display piece. Here, the Tesla Optimus Gen 3 is creating a true revolution with the new generation 4680 battery. Fast charging capability and sophisticated thermal management, transforming the robot from a futuristic concept into a tireless worker. This is not just a story about a battery. It is a story about how Tesla is redefining the concept of a truly useful robot in real-world applications. The 4680 battery is the heart of Optimus. It delivers high energy density, storing more power in the same volume compared to traditional cells, which means the robot can move, lift heavy objects, perform delicate tasks, or care for humans for hours on end without needing a break. The 3 kilowatt-hour pack allows the robot to operate continuously for 8 to 11 hours, equivalent to a full human work shift, sufficient to complete a series of complex tasks in factories, warehouses, service environments, or households. Imagine a working day for Optimus in a factory. The robot begins by moving constantly between the warehouse and assembly line, lifting parcels weighing 10 to 25 kilograms, stacking them onto conveyors, checking quantities and component placement, then returning to the starting point. During the first 2 to 3 hours, the 4680 battery provides enough energy for the robot to perform these heavy-duty tasks while maintaining high speed and precision. Beyond transporting materials, Optimus can also handle more delicate operations, such as assembling small components, inspecting electronic parts, or controlling mechanical arms with millimeter-level accuracy, a level of finesse that many other robots cannot sustain continuously. Between hours 5 and 7, the robot continues with less physically demanding but still continuous tasks, such as organizing the warehouse, cleaning workspaces, inspecting work areas, or assisting in production line supervision. In a household setting, this phase corresponds to Optimus cooking, cleaning, caring for children or the elderly, tasks that are less physically strenuous but require continuous movement, real-time sensor data processing, and immediate decision-making. Thanks to advanced thermal management, the 4680 battery does not overheat even during prolonged operation, ensuring stable performance and long lifespan. During hours 7 to 9, the robot handles monitoring, inspection, and data updating tasks, or serves users by reminding schedules, tracking electronic devices, or overseeing security. These activities consume less energy but still demand continuous, precise, and flexible operation. Through intelligent energy distribution, Optimus can prioritize power for tasks that require more mechanical effort, such as lifting or continuous movement, while reducing consumption for less energy-intensive actions, optimizing both energy use and operating time across a full work shift. Another remarkable feature is the 10-minute fast charging capability and automatic docking module charging. This transforms Optimus into a robot that can operate almost 24/7, uninterrupted by low battery. In a warehouse over 1,000 square meters, the robot can lift and arrange dozens of packages, check quantities, return to the dock for a quick recharge, and continue a second work shift without performance loss. In households, the robot can continuously clean, cook, care for the elderly, and monitor devices while recharging or swapping its battery in minutes without human intervention. What is particularly notable is that the 4680 battery is not only powerful, but also cost-effective. It is the lowest cost cell among Tesla's lineup, thanks to advanced design and production processes. Tesla is also implementing lithium refining and cathode production in the U.S., securing supply chains, reducing dependence on China and other countries, and ensuring large-scale production and continuous operation. With this strategy, the Optimus Gen 3 is not merely an experimental robot, but a practical tool capable of replacing humans in repetitive and delicate tasks. Another critical point is the robot's ability to perform tasks continuously. It can lift heavy objects, move tens of kilometers across factories or warehouses, then switch to delicate operations such as assembling components, caring for humans, cooking, or cleaning without needing a break. This is all made possible by the combination of high-capacity batteries, intelligent thermal management, and fast charging, creating a durable machine with stable performance and maximum productivity. Once again, please help us reach 20,000 subscribers. This is important for us to stay motivated. Thank you. How does AI and energy-efficient design optimize Optimus's performance in each task? One of the groundbreaking strengths of the Tesla Optimus Gen 3 lies not only in the 4680 battery, or its 3 kilowatt-hour capacity, but also in the combination of advanced artificial intelligence and optimized mechanical design, which enables the robot to perform each task with maximum energy efficiency. Here, AI and lightweight design not only enhance work performance, but also minimize energy waste, ensuring the robot can operate for many hours without excessively wearing down mechanical systems. This is an important step toward transforming humanoid robots from heavy, power-hungry machines into truly intelligent and flexible tools for both daily life and industrial applications. One of the most notable features is Tesla's full self-driving FSD AI, integrated into the robot's hand control and operational mechanisms. The FSD AI not only directs movement and recognizes objects, but also calculates the exact force needed for gripping or lifting objects. For example, when the robot lifts a box, the AI adjusts the grip just enough to lift it without applying excessive force, preventing the item from dropping while saving energy. This is a crucial factor, as humanoid robots often consume large amounts of energy when using excessive force, especially for tasks repeated dozens of times within a single shift. With FSD AI, every hand movement is optimized. Just enough force, proper timing, allowing the robot to complete tasks with minimal battery consumption. For instance, in a warehouse, Optimus can lift dozens of parcels from a conveyor to shelves. The AI calculates the necessary force for each parcel, avoiding energy waste from redundant motions while reducing mechanical wear on the hand joints. The second key point is the high-efficiency electric motors, an essential mechanical component specifically designed by Tesla for humanoid robots. These motors not only enable fast movement, but also reduce energy consumption during continuous operation. For long tasks such as warehouse patrols, facility monitoring, or full area cleaning, the AI combined with high-efficiency motors optimizes travel distance, reduces friction, and ensures each step is as energy efficient as possible. Unlike many other robots, Optimus Gen 3 does not rapidly drain energy during continuous hours of movement, thanks to intelligent motor control integrated with obstacle detection sensors and environmental mapping. This allows the robot to complete tasks spanning an entire work shift from morning to evening, without frequent breaks or additional charging. For example, when patrolling a 2,000 square meter warehouse, the robot moves while monitoring, sorting goods, and updating data, all optimized to reduce energy consumption, while FSD AI ensures no object in its operating area is missed. The third key factor is the lightweight design, with Optimus Gen 3 weighing only about 55 kilograms, significantly lighter than many other humanoid robots on the market. The low weight provides a dual advantage. It reduces friction and resistance during movement, saving energy with every step, and it makes the robot more agile when performing repeated tasks. In a warehouse, when the robot needs to move dozens of packages from one conveyor to another, the low weight allows the motors to consume less energy, reduces wear, and extends the lifespan of mechanical systems. For delicate tasks, such as arranging small components or assisting in assembly operations, the lightweight design helps the robot adjust its posture more easily, grip objects precisely, and maintain optimal energy consumption. This is especially important when the robot performs hundreds to thousands of repetitive tasks daily, from industrial environments to households. The combination of FSD AI, high-efficiency motors, and lightweight design creates a comprehensive energy optimization system, not only saving battery power, but also increasing the robot's ability to perform complex tasks continuously. Every hand movement, step, or full body motion is calculated by the AI based on object weight, travel distance, required speed, and task duration. The result is a robot that operates reliably, intelligently, and efficiently, avoiding wasted energy from redundant movements while reducing strain on the battery, motors, and mechanical systems. Additionally, thanks to AI and energy-efficient design, the robot can adjust its task execution strategy according to the environment. In a large warehouse, the AI calculates optimal routes, minimizes unnecessary movements, and applies only the force required for lifting heavy items. In a household setting, The robot adjusts its steps and grip strength when carrying light objects, cooking, or cleaning, ensuring energy is conserved and operations remain continuous. This flexible adjustment capability allows Optimus to perform a wide range of tasks while maintaining maximum energy efficiency, something most other humanoid robots have not yet achieved. Another example is when the robot performs a continuous sequence of tasks, such as lifting 50 packages, arranging them on shelves, checking quantities, and returning to the starting point to continue a shift. With FSD-AI, each movement is optimized. The grip force is precise, travel distance minimized, motors operate efficiently, and the lightweight frame reduces energy consumption, all together creating an intelligent, efficient, and durable operating system that allows the robot to complete long tasks without frequent charging or breaks. Finally, this system also enhances the robot's lifespan and durability. Optimized hand force, reduced weight, and high-efficiency motors not only save energy, but also reduce mechanical wear. This means the Tesla Optimus Gen 3 can operate reliably throughout the day while maintaining consistent performance over years of use, making the robot a truly valuable investment for businesses, factories, warehouses, or households. Why does Tesla apply this new battery only to the V3 Optimus? One of the factors that makes the Optimus V3 particularly special compared to previous versions is that only V3 is compatible with the new generation battery, and this is no coincidence. It's the result of multiple layers of design, testing, and unique engineering strategy. During development, Tesla realized that integrating the new battery was not simply a matter of placing it into the old robot frame. Instead, V3 features a completely new electrical circuitry structure designed to control voltage, current, and battery state feedback in real time, ensuring stable and safe operation. Version 1 and Version 2 lack these complex regulatory circuits. Even if the new battery were installed, the robot would not properly recognize energy efficiency levels, which could lead to overload or instability. In addition, V3's energy management software and sensors were developed specifically for this version. They not only monitor battery status, but also coordinate with the hardware system to adjust surrounding electronic modules. These sensors track temperature, current, and the operational state of each mechanical component, ensuring that the new battery not only works, but also maintains stable operational cycles for many continuous hours. This is why Tesla decided to limit the new battery exclusively to V3. Older versions do not have sufficiently advanced software to manage the complex interactions between the battery and mechanical systems, increasing the risk of operational errors. Another factor is safety testing and quality standards. V3 is the only version that has undergone thousands of hours of testing with the new generation battery across multiple environments, from factory and warehouse operations to household settings, to evaluate its response to unexpected situations. These tests not only assess energy performance, but also monitor battery behavior, as the robot performs continuous tasks under varying speeds and load conditions. Previous versions have not undergone such testing and are therefore not qualified to safely integrate the new battery. The production strategy is also an important technical reason. The new battery requires a proprietary frame and electrical interface that Tesla has only implemented on version 3. Connectors, plugs, and voltage regulators are all designed to the new standard, allowing the battery to be installed on V3 without modifying the external structure or adding additional modules. Applying these components to version 1 or version 2 would require a complete redesign of the mechanical frame, which Tesla has not done, as they are prioritizing research, testing, and optimization for V3. Furthermore, limiting the new battery to V3 reflects Tesla's phased market and product development strategy. Tesla uses V3 as a testbed for advanced technology, both to demonstrate the integration of the new battery and to collect real-world operational data before expanding to future generations of robots. This ensures that all future robots will operate reliably with advanced batteries while reducing safety and warranty risks. Another important aspect is the optimization of the cooling system and electronic protection specifically for this battery. The new battery can handle high currents, but without synchronized circuit boards and cooling fans, overall performance would decrease and the robot's lifespan could be affected. V3 features a cooling system, sensors, and electronic protection circuits optimized specifically for the new battery, ensuring stable operation under all environmental conditions. Older versions lack these improvements, so using the new battery could lead to overheating or accelerated wear. The world of AI robotics has just reached another significant milestone, with Tesla unveiling the Optimus Gen 3, a revolutionary new AI brain that takes humanoid robotics to an entirely new level. This groundbreaking development sets Optimus Gen 3 apart from its competitors, thanks to its enhanced processing power, rapid decision-making capabilities, and advanced autonomous functions. In this article, we'll dive deep into the remarkable improvements how Tesla Optimus achieve faster decision-making and enhanced processing power. Before we begin, please help us reach 20,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla tech and the latest news. Tesla's new AI brain is designed to think faster than any other humanoid robot. Powered by Tesla's custom Dojo supercomputer, the new brain is engineered for rapid data processing, enabling Optimus Gen 3 to make decisions in real time with remarkable speed. The upgraded system uses advanced neural networks that process information at lightning speed, allowing the robot to execute tasks with agility and precision. Whether Optimus Gen 3 is assembling parts on a factory floor, providing care for the elderly, or even performing intricate household chores, its to react to environmental changes has reached a level of speed and sophistication never before seen in robotics. Unlike the earlier versions of Tesla Optimus, which relied on slower processors for decision-making, the new AI brain leverages Dojo's processing power to carry out tasks that require complex decision-making in mere milliseconds. This is a huge leap forward compared to earlier humanoid robots like Boston Dynamics' Atlas, whose processing speed is impressive but still lacks the real-time reaction and autonomous learning capabilities of Optimus Gen 3. How could Optimus Gen 3 enhance sensory processing? One of the most impressive upgrades to Optimus Gen 3 is its new perception system. The robot now incorporates high-resolution cameras, depth sensors, and a new suite of tactile sensors embedded in its hands, enabling it to process sensory inputs, whether visual, tactile, or auditory, in real time. This allows Optimus Gen 3 to identify objects, obstacles, and even people with pinpoint accuracy, even in complex and dynamic environments. Compared to Atlas, which has an advanced vision system and high-performing sensors, Optimus Gen 3 goes a step further by processing visual and sensory inputs at a much higher rate, which makes its object recognition faster and more accurate. The ability to assess the environment rapidly is vital for complex tasks, such as navigating through crowds, picking up delicate objects, or responding to unexpected movements. Moreover, Optimus Gen 3's new sensory fusion capabilities allow it to feel the weight and temperature of objects in real time. This, in turn, helps the robot adjust its grip accordingly, making it capable of handling delicate tasks like assembling electronics or pouring a glass of wine with the precision of a human. While Atlas can execute tasks involving physical interaction with objects, Optimus Gen 3 excels in tasks that require a delicate touch and fine motor skills, traits that will make it more suitable for a wider range of applications. What truly sets Optimus Gen 3 apart from Atlas is its ability to learn and adapt to new environments and tasks autonomously. Tesla has integrated cutting-edge reinforcement learning algorithms into the new AI brain, allowing Optimus Gen 3 to improve its efficiency by learning from each interaction and refining its actions over time. Unlike previous versions, which required human input and adjustments for specific tasks, Optimus Gen 3 now has the ability to fine-tune its behavior based on real-time feedback from its surroundings. For instance, if Optimus is placed in a new environment, whether it's a home, a factory, or a busy street, it can autonomously learn the best way to interact with that space. This means Optimus can adjust its movements, responses, and decision-making processes without requiring manual programming. This self-improvement mechanism is a huge leap forward from Atlas, which, while capable of learning specific tasks, still requires significant human oversight for task optimization. Tesla's introduction of the adaptive learning system in Optimus Gen 3 is a game-changer. By continuously adjusting to human actions and environmental changes, Optimus is able to perform tasks in a way that is not only efficient, but also more human-like. This makes it more versatile in environments where human interaction is key. Another standout feature of the new AI brain is its speed, made possible by Tesla's Dojo supercomputer. Dojo is specifically designed to handle massive AI workloads, processing trillions of data points per second. For Optimus Gen 3, this upgrade means that the robot can think and react far faster than its predecessors. This speed improvement directly impacts Optimus Gen 3's ability to interact with its environment in real time. Whether it's adjusting its movement to avoid a human, calculating the best way to grab an object, or fine-tuning its task execution, the new AI brain processes information and takes action almost instantaneously. This results in a higher degree of precision and fewer delays, making Optimus Gen 3 a much more efficient robot, capable of completing tasks with minimal error. When compared to Atlas, which still faces limitations in decision-making speed, Optimus Gen 3's enhanced processing speed positions it as a far more efficient and capable humanoid robot. While Atlas is an impressive machine, Optimus Gen 3 offers a substantial advantage when it comes to executing complex tasks at scale, making it the more practical solution for real-world applications. In addition to speed and precision, Tesla has incorporated a new energy management system into Optimus Gen 3, making the robot not only faster but also more energy efficient. The system optimizes how the robot uses power during task execution, allowing it to run longer on a single charge compared to its predecessors. This energy efficiency is crucial for real-world applications where battery life is essential. Whether it's working in a factory for long shifts or performing household chores throughout the day, Optimus Gen 3 can stay operational for extended periods without the need for constant recharging. This makes it a much more practical solution for industries that require robots to be on the job for hours at a time. In contrast, Atlas, while capable, struggles with battery life, particularly in long-duration tasks. What Tesla's vision for humanoid robots in the future? With the release of Optimus Gen 3 and its new AI brain, Tesla is redefining what humanoid robots can do. The new system marks a huge leap forward in AI, robotics, and machine learning, with a focus on creating robots that can work alongside humans rather than replacing them. Tesla's goal has always been to create a robot that can perform complex tasks with precision and efficiency, and the Gen 3 AI brain is a major step toward achieving that goal. Optimus Gen 3 has the potential to revolutionize a wide range of industries, from manufacturing to healthcare, retail, and even space exploration. Tesla's continuous development of the Optimus platform ensures that Gen 3 will only continue to improve, with each iteration bringing more advanced features and capabilities. The story begins with a comparison. Previous generations of Optimus, such as the early prototypes and the more stable Gen 2, already impressed users with their balance, dexterity, and pre-programmed set of household actions. Gen 2 could clean surfaces, carry packages, and perform repetitive motions with remarkable accuracy. But its adaptability was limited. To learn new tasks, additional programming or cloud updates were often required, pushed by Tesla's engineers. In practice, this made the robot highly capable in structured environments, but somewhat rigid when confronted with the unpredictability of human households or workplaces. Boston Dynamics Atlas or Agility Robotics Digit had similar limitations, excelling in mobility, but struggling with fluid adaptation to novel instructions. Optimus Gen 3.5, however, transcends this bottleneck with a system that mimics the way humans acquire skills in early childhood: observation, imitation, and iterative optimization. When a new Gen 3.5 unit is delivered to a customer, its first 3 days are not merely operational, they are developmental. During this window, the robot is directly linked to Tesla's Dojo supercomputer network, a training platform that processes exabytes of multimodal data. Dojo is not only responsible for powering Tesla's full self-driving neural nets, but also supports the Optimus architecture. The robot arrives with a generalist foundation model trained on millions of recorded scenarios, from folding laundry to navigating crowded hallways. Yet the breakthrough lies in how this foundation rapidly personalizes itself. In the first 72 hours, Optimus collects terabytes of visual and tactile data from the owner's home, analyzing the unique layouts, tools, and interaction patterns. Through edge-level inference and Dojo-assisted cloud reinforcement, the robot compresses what might normally take weeks of fine-tuning into just a handful of days. The efficiency of this process can be quantified. According to Tesla's internal benchmarks, a single Tesla Optimus can achieve over 90% task success rates on 200 household activities by the end of its third day in a new environment. For comparison, most industrial robots, even those costing upwards of $80,000, require specialized engineers and weeks of manual calibration to approach that level of versatility. The numbers are staggering. In controlled trials, Optimus reduced adaptation time by a factor of 15 compared to legacy humanoid systems. One study recorded that by the 48-hour mark, a newly deployed unit could reliably execute 150 unique commands from setting tables to assisting elderly users with mobility support. By hour 72, that number exceeded 300, effectively covering the vast majority of daily household needs. How does Optimus achieve this insane ability? The core mechanism is its tri-layered learning model. At the base level, pre-programmed motor primitives enable the robot to move its limbs with human-like smoothness. Each joint carries micro-actuators capable of sub-millimeter precision, operating at frequencies up to 1,000 Hz. On top of this foundation lies a self-supervised vision-language model, allowing Optimus to map verbal commands and observed demonstrations into actionable representations. If an owner demonstrates how to slice vegetables or load a dishwasher, Optimus not only mirrors the physical actions, but also tags the contextual meaning behind them. Finally, reinforcement optimization closes the loop. Every action is evaluated against success criteria. These feedback loops feed directly into the dojo servers, where the data from thousands of households converge, ensuring that every Optimus improves the collective intelligence of the fleet. The impact of this distributed learning system cannot be overstated. It is reminiscent of Tesla's approach with self-driving vehicles. Each car on the road functions as both product and data collector, streaming edge cases back into the central training engine. For Optimus, the household becomes the laboratory. If one robot in Tokyo struggles to fold a non-standard futon blanket, the experience enriches the dataset for a robot in Berlin tasked with similar bedding. Within weeks, the entire fleet collectively knows how to handle the task. Yet for the individual owner, the learning curve is nearly instantaneous. What seems like a personal robot mastering unique chores in 3 days is actually the power of a global swarm intelligence converging in real time. Financial implications also enter the picture. Tesla has hinted that Optimus could eventually be priced around $20,000, a fraction of what traditional humanoid robotic systems cost. If the robot can execute over 5,000 tasks and generate value, estimated at $5,000 per month in labor substitution or service creation, the return on investment is extraordinary. Consider an elderly care facility. By the end of the first 3 days, Optimus units can already assist patients in walking exercises, deliver meals, and provide reminders for medication schedules. Such tasks, when performed by human staff, represent thousands of dollars of monthly wages. By augmenting human caregivers, rather than replacing them, Optimus not only reduces costs, but also raises the standard of attention each patient receives. In household contexts, the math is similar. An Optimus that can clean, cook, and handle errands within 3 days of delivery saves families dozens of hours per week, equivalent to hiring multiple part-time assistants. Critics may argue that these numbers are overly optimistic, or that human unpredictability cannot be compressed into 3 days of adaptation. Yet, Tesla's internal testing aligns with empirical demonstrations. Optimus Gen 3.5 was shown to identify novel objects within seconds, learn a previously unseen kitchen layout in minutes, and carry out multi-step instructions with fewer than 5 repetitions required for mastery. In controlled trials with 100 households, 93% of users reported that their robot had become competent in handling daily chores within the first 3 days, with satisfaction scores exceeding 4.7 out of 5. Such consistency suggests that the system is not merely aspirational marketing. Tesla has once again broken barriers with the release of Optimus version 3, an upgraded humanoid robot that redefines the capabilities of artificial intelligence and robotic dexterity. The new version of Tesla's Optimus brings with it a major breakthrough, a highly dexterous hand capable of performing complex tasks with exceptional precision. This cutting-edge development signifies a monumental step forward in humanoid robotics and positions Tesla as a leader in the quest for creating robots that can seamlessly integrate into human environments. How Optimus's new AI hand will help Tesla outpace every competitor in the market. Stick around. In the next 30 seconds, I'll show you Tesla's most secret update about Optimus. Before we begin, If you love staying ahead on Tesla and AI tech, hit subscribe now. You'll be the first to know the breaking news. Tesla's vision for Optimus goes beyond simple tasks. It is about creating a robotic workforce that can support human labor in various industries. With this latest update, Tesla Optimus Gen 3 takes a giant leap in becoming more than just a machine. It now boasts a dexterous hand that enhances its ability to perform highly specialized tasks with precision. The new dexterous hand of Optimus Gen 3 represents a major upgrade in the design of robotic appendages. The previous versions of humanoid robots, including Tesla's own Gen 2, had hands capable of performing basic tasks. However, these hands lacked the fine control and dexterity required for tasks that demand human-like precision, such as assembling delicate components or interacting with fragile objects. Optimus Gen 3's hand, however, is a game-changer. With 24 degrees of freedom, the hand can move in a variety of ways that mimic human hand movements. This is a significant improvement over earlier designs, where the robot's hand movements were more rigid and mechanical. The 24 DOF allows the Optimus Gen 3 hand to grip, twist, rotate, and manipulate objects with a level of accuracy that was once unattainable in robots. This design incorporates advanced sensors that detect the weight, size, and texture of objects, allowing the robot to adjust its grip accordingly. For example, Optimus Gen 3 can pick up a glass with gentle precision and turn a wrench with the force necessary for tightening bolts. This level of control and adaptability makes the Optimus Gen 3 hand suitable for a wide range of applications, from factory automation to home assistance. In addition to physical dexterity, the hand is connected to Tesla's AI platform, which allows the robot to learn and refine its movements over time. This means that Optimus Gen 3's hand can adapt to various tasks and environments, improving its performance as it gains experience. This learning ability is crucial for tasks that require ongoing precision and efficiency. Whether it's working in a warehouse or assisting in elderly care, the hand's flexibility ensures that the robot can perform tasks effectively in diverse settings. How Optimus Gen 3 stands out in the robotics industry. The field of humanoid robots has seen various developments, but Tesla's Optimus Gen 3 is proving to be a pioneering force in this space. To understand the significance of Optimus Gen 3, it's important to compare it with some of the leading humanoid robots and their capabilities. One of the key competitors to Tesla, Optimus Gen 3, is Boston Dynamics' Atlas robot. The Atlas is known for its agility, being able to perform impressive stunts like backflips and parkour. However, while Atlas excels in mobility and agility, its hands are not as dexterous as Optimus Gen 3. However, Unitree Robotics' Dex 5, another competitor, is another robot that features a dexterous hand, with only offers 16 degrees of freedom, fewer than the 24 DOF of Tesla Optimus Gen 3. This gives Optimus Gen 3 an edge in terms of hand dexterity and range of motion. The Tesla hand also benefits from its integration with Tesla's AI platform, which allows it to perform tasks with a level of adaptive learning that the Unitree Dex 5 does not currently offer. While Unitree Dex 5 is designed to handle precision tasks, its learning capabilities and real-time adaptability are limited compared to Tesla's version. When comparing Tesla Optimus Gen 3 with these robots, it's clear that Tesla has taken a more holistic approach to the design and function of the robot. Optimus Gen 3 combines advanced mechanical dexterity with the power of artificial intelligence, creating a robot that can perform a wide range of human-like tasks naturally and efficiently. The release of the Optimus Gen 3 and its dexterous hand opens up new possibilities for robotics in a variety of industries. The robot is not just an innovation for laboratories or research facilities, but it is also ready to be deployed in real-world scenarios where human labor is often in short supply. In manufacturing, for instance, Optimus Gen 3 can be used to assemble products with high precision, handle delicate components without damage, and assist with quality control. The robot's ability to manipulate tools and interact with objects makes it ideal for tasks that require both strength and delicacy. In the healthcare sector, the Optimus Gen 3 robot could be used in hospitals or clinics to assist with surgical procedures or patient care. The dexterous hand allows the robot to handle surgical instruments with precision and can even be used to assist medical professionals with complex tasks such as administering injections or performing diagnostic procedures. Additionally, the robot's ability to learn and adapt could make it a valuable tool for remote healthcare applications, where the robot could assist medical staff in performing tasks from a distance. The service industry also stands to benefit from Tesla's advancements. The Optimus Gen 3 robot could be deployed in elderly care, where it could assist with daily activities such as cooking, cleaning, or medication management. Its dexterity would be particularly useful for handling fragile materials like medications or food, tasks that are difficult for most current robots. Furthermore, the robot's AI learning capabilities would allow it to provide personalized assistance, adapting its actions to the needs of each individual. As Tesla continues to refine the Optimus Gen 3, the potential applications in sectors like hospitality, logistics, and education are limitless. Tesla is setting the stage for the next generation of humanoid robots. The advancements in dexterous hand technology and AI learning are just the beginning of what could become a wide-scale integration of robots into daily life. The Optimus Gen 3 is just one step in Tesla's vision of creating robots that can enhance human life and productivity. As Tesla continues to innovate, we will likely see even more sophisticated features and improvements in future versions of Optimus. Looking ahead, the integration of 5G networks, advanced AI, and machine learning will further enhance Optimus's capabilities, making it even more autonomous and capable of interacting with smart environments. Tesla's continuous improvement of Optimus Gen 3 could lead to a future where robots are seamlessly integrated into workplaces, homes, and communities, working alongside humans to accomplish tasks that were once thought to be impossible. The most striking aspect of Musk's statement is that Gen 2.5 is not just a prototype. It is a bridge between earlier designs and the upcoming Gen 3, and the details he revealed demonstrate why this intermediate generation matters. Compared to the Gen 2 platform shown publicly in 2023, the Gen 2.5 Optimus has already undergone a series of design optimizations that reduce weight, increase balance, and improve joint articulation. Most notably, Musk confirmed that Gen 3 will feature a highly sophisticated human-like hand design with 26 degrees of freedom, rivaling the dexterity of a trained human operator. To put this into perspective, human hands generally possess around 27 degrees of freedom, and most commercial robots currently manage fewer than 12. By nearly doubling the articulation of Optimus compared to earlier Tesla versions, Musk is signaling that Tesla intends for the robot to handle tasks far beyond simple lifting and repetitive motions. It will be capable of manipulating delicate objects, typing, preparing food, or even performing complex maintenance in both homes and industrial environments. Equally shocking to analysts was the pricing announcement. In the early stages of Optimus development, many predicted that Tesla's humanoid robot would cost upward of $20,000 to $25,000, putting it squarely in the domain of corporate buyers, laboratories, and wealthy early adopters. Musk, however, has set the price of Gen 3 at just $8,000, instantly positioning the robot as a consumer-level product rather than an elite technology. If Optimus costs $8,000 upfront, it is essentially priced at the level of a single year of service work, yet it promises to operate for over a decade with only minor maintenance. This comparison underscores why Musk referred to Optimus as a product intended to become as common as electric cars. It is not simply a tool for corporations, it is a robot aimed at every household. The production numbers Musk cited further reinforce that intention. Tesla aims to scale manufacturing to 500,000 robots annually by 2027, a figure that rivals the production scale of entire automotive segments. For context, BMW produced approximately 2.5 million cars globally in 2023, while Tesla produced just over 1.8 million electric vehicles in the same year. For a robotics platform to reach 500,000 units per year within just 3 years signals not only Tesla's confidence in its supply chain but also its belief that demand will be widespread. Musk has consistently argued that the bottleneck in robotics is not design but scaling. Just as Tesla solved the mass production of lithium-ion batteries when few believed it was possible, Musk is betting that Tesla can achieve the same industrial breakthrough for humanoid robots. The weight reductions and structural optimizations in Gen 2.5 are critical for this scalability. Earlier versions of Optimus weighed over 160 pounds and required significant power to operate smoothly. By revising frame materials, integrating lightweight alloys, and redesigning actuators, Tesla has reportedly reduced the weight closer to 125 pounds in Genesis 2.5, while maintaining a height of approximately 5 feet 8 inches, comparable to an average adult human. This not only reduces energy consumption, but also makes the robot safer in domestic environments. A lighter robot with advanced balance algorithms is less likely to cause accidental harm and can maneuver more easily through cluttered living spaces. In addition, Tesla's integration of its automotive camera systems into Optimus gives it advanced vision at low cost, leveraging economies of scale from car production. Gen 2.5 uses multiple high-resolution cameras positioned in both the head and torso, supported by Tesla's full self-driving neural networks adapted for humanoid mobility. This fusion allows the robot to navigate dynamic spaces, recognize objects, and avoid hazards in real time, much as Tesla cars can identify road conditions and obstacles. One of the boldest parts of Musk's vision is the shift in public perception about what robots are meant to be. For decades, robotics has been divided into two worlds: industrial robots, which are expensive and highly specialized machines in factories, and speculative humanoid robots, which remained mostly in research labs or science fiction. Musk is collapsing that distinction. By declaring that Optimus will be priced like a household appliance and produced in volumes rivaling mainstream vehicles, he's effectively announcing the beginning of a consumer robotics era. If Tesla achieves its target, there could be millions of Optimus units in circulation by the end of the decade, a figure that dwarfs all existing humanoid deployments combined. According to the International Federation of Robotics, fewer than 200,000 service robots for professional use were sold worldwide in 2023, most of them limited to niche functions like warehouse handling or medical assistance. Tesla's 500,000 per year goal would single-handedly increase the global humanoid robot population several times over. The affordability and potential ubiquity of Optimus also carry profound economic implications. At $8,000, a robot can be financed much like a car. Spread over a 5-year loan, monthly payments could be as low as $140, a cost lower than many household internet or phone bills. If the robot is capable of performing cleaning, cooking, basic childcare support, and elderly assistance, then the return on investment becomes obvious. Households would save both time and money while gaining an always available assistant. For businesses, the equation is even clearer. A restaurant could deploy 5 Optimus units for $40,000 total, far less than annual labor costs for staff. A warehouse could operate hundreds of units without worrying about overtime, insurance, or turnover. These economic realities are why investors quickly began recalculating the valuation of Tesla's robotics program after Musk's confirmation. Some analysts projected that if Tesla captures even 5% of the global household robotics market, it could add hundreds of billions of dollars to its long-term revenue streams. However, Elon Musk has repeatedly said that Tesla's mission is to accelerate the advent of sustainable energy. But with Optimus, the mission expands to accelerating sustainable labor. In Musk's view, repetitive and physically demanding tasks should be automated, freeing humans for creative, intellectual, and emotional pursuits. Optimus, with its lighter frame, improved dexterity, and reduced cost, demonstrate that Tesla is not simply experimenting. It is engineering toward a future where robots become companions, assistants, and collaborators in everyday life. Musk even described Optimus as something that should become as universal as cars, suggesting that he envisions a world where having a humanoid robot in one's household is no more unusual than owning a washing machine or a smartphone. Skeptics, of course, point to challenges. Can Tesla truly ramp to 500,000 units per year, given the complexity of humanoid robots? Will safety regulations adapt quickly enough to allow widespread domestic use? Can an $8,000 price point be maintained once supply chain pressures are accounted for? These questions are valid, but they are also reminiscent of doubts about Tesla's electric cars 15 years ago. Many believed Tesla could never produce affordable EVs at scale, yet today the Model 3 and Model Y are among the best-selling vehicles in multiple countries. Similarly, critics said battery storage would never be profitable, yet Tesla's Megapacks, Megablocks, and Powerwalls are reshaping energy grids. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.